today we're going to do some summarization. We've been doing so much work on quadratics, and now we're going to go ahead and talk about how to tell which technique to use in order to solve and find the roots in order to graph a parabola. So we're going to look for that easiest technique. We're going to talk about something called perfect square form, and then we're going to say, well, what does this one specific form help me see quickly and help me understand? So let's go ahead and jump right in. So this is our mixed quadratic notes. And we're going to kind of have three different parts to it. So we're going to go ahead and cut our book here into thirds. Okay. So our first little thing that we're going to talk about is the easiest quadratic technique. And this is to find the roots. When our goal is, when we're given in standard form and we want to go ahead and find the roots so that we can graph that parabola. So we're going to go ahead and look at three different little items here. And our first technique that we learned to use was a diamond problem and a generic rectangle. And we can use that if it kind of looks factorable, easy numbers. Or if it's already factored. And that is if, for example, it's in product form, like y is equal to 2x minus 1 times x plus 5. So that is really nice because that way we already have that given to us. Now, the second is a technique that if you love math, I want you to look more into. We're not going to talk a lot about it this year just because we're running out of time, but you will run into this in Algebra 2. And this is called completing the square. And during class one day, I'm going to walk you through how to do that. But what happens is when you get and you're working on your diamond problem and you have something like a 7 and a 3, we know the only way to multiply to get a 7 is 1 times 7, and those don't add or subtract to get a 3. So sometimes we use complete the square when it's not factorable using that diamond problem. And we like to complete the square when there is a plain x squared. We don't like there to be a number in front of our x, otherwise it's a lot more work. And it's also nice if b is an even number. That's an E right there, is an even number. So remember, b is the number in front of the x. So if that's an even number, because we're going to half that, then that completing the square is an option. And like I said, this is a technique we're not going to work on a lot this year, but you should be aware that that is a technique. Now, the one that we are going to spend a lot of time on is the third one, and it's called the quadratic formula. And this one works all the time. There's never a point where you run into it and all of a sudden you're like, oh no, that's not going to work. This will work for everything. So we like to use this when there might be some decimals or fractions involved. And if the numbers are large for your A, B, and C, or if I like to call like ugly, they're just ugly numbers. You don't even want anything to do with that. And we're going to be working on this next class, but I wanted to go ahead and tell you what the quadratic formula is here because we want you to start to kind of see what that is. So this is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac. And then we're going to take that entire part, that is going to be a fraction all over 2a. And if you were in class, we actually at this point would have you start to memorize that, and you would have to sing it to come into the classroom. There's a lot of fun videos out there that I'll be showing you in class this day. But basically, one of my favorites, Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a lot of fun ones that we can use. But that is always going to work. So it's the same kind of start where you pull out your A, B, and C from standard form, and then you just plug those numbers in and solve using order of operations. The issue with this, of course, is there are a lot of places for error as you're solving. Okay, our second part that we're going to talk about here is perfect square form. And perfect square form is when on one side you have ax plus b squared, and on the other side you have your constant c. And you can rearrange anything into perfect square form. And what this c tells you is once you look at that letter c, it tells you how many x-intercepts or roots or zeros or solutions the parabola has. So we know that when we have a parabola, there are three options. We can have our parabola cross in two places, the x-axis. We can have our parabola touching at one spot, or we can have our parabola not have any x-intercepts. So when we get everything over to one side except for our constant, that c is going to tell us whether it has two x-intercepts, one x-intercepts, or zero x-intercepts. So when we have that c isolated and that number c is a positive number, then it has two solutions. Now remember, solutions is also roots, zeros, and x-intercepts. Now if that number is 0 on the side, ax squared plus b, ax plus b squared equals 0, then there is one solution. However, if the number on the right side is a negative number, like a -5 and -12, then there is no solution, which means there's no roots, and it looks like this, and it does not cross the x-axis. So when there's 2, it's a positive number. When it touches once, it's a 0 for C. And when we have no roots, it never crosses the x-axis, then we know that constant is negative. So that's what we have for perfect square form. Now, the last part that we're going to talk about today is forms of a quadratic equation. And once again, we know that there are three. There's more than three, but there's three that we've used and talked about a lot this first year of Algebra 1. So first we have standard form. We have vertex form. And we have our product form, also known as factored form. Lots of names for a whole bunch of math stuff. So in standard form, we know it's ax squared plus bx plus c. And an example of that is something like 3x squared minus 4x plus 5. Now, why is this useful for us? It's useful because of the c. This right here is our y-intercept. And so if we are just look at the equation, we can just look at that plain number and know that we can plot that on the y-axis. Now, our vertex form has the formula. Write that in red. Y is equal to a times x minus h squared plus k. An example of that is y is equal to x plus 4 squared minus 7. Now, we know that we take the opposite of the first and the number exactly on the outside, and that is our vertex. So -4, -7 in this case, and this tells us the vertex. Now, once again, we can see these things given these equations without doing a lot of extra math. It's just a visual thing. Oh, look, that's the y-intercept. Oh, look, the opposite of this, -4, and the same on the outside, 7. And so when we have a whole bunch of different forms of the same one, we get a whole bunch of information. Lastly, we have our factored form, and that is, for example, y is equal to x minus p times x minus q. Okay, and an example of that could be y is equal to x plus 7 times 2x minus 1. And we know that from this, we simply set each of them equal to 0, and we easily find the roots. So depending on the type of our type of situation that we're given, we can find some information without doing a lot of math. So if we have one equation broken down into all three forms, then that is really nice because we can actually graph an entire quadratic parabola without doing as much math as we potentially would using one of our techniques up above. So ladies and gentlemen, we're going to continue our journey on parabolas. And next class, we're going to learn and focus on the quadratic formula. So be ready for a lot of calculator work. Let's go ahead and practice some more quadratics in our Desmos activity.